So we're on our journey to work out how we can create a spreadsheet, an Excel spreadsheet, which will create a neural network that we can train to recognize handwritten digits. Here we can see that it's managing to recognize a 3, and if I cycle it round, it's able to recognize other digits. What we did previously was we created a neural network which is much simpler, with one input neuron, one hidden neuron, and one output neuron. We then fed the data through the neural network to calculate the output of the hidden bias, fed it into the into the hidden neuron. We fed the output of the hidden neuron into the output neuron and calculated the resulting value. Our target was 0.6 and we calculated the overall error. I've made a few changes. I've renamed the spreadsheet worksheets to make them more meaningful. So I've called this one the neural network because it's going to have the full neural network in there. We explored the sigmoid function, so I've renamed that. I've created 4 additional worksheets. What this worksheet does is it fixes the value of weight 5 and then runs the value of weight 1 through from -1 to 10, and it plots the resulting error value. So we can see here that the around 2.8 we get a very low error value. In fact, even over here the values are not particularly large, but you can see the curve of the chart for weight 1. Clearly what we need to be doing here is working out whether we are to the right of or to the left of the minimum. So if we're over here and we're to the left of the minimum and we are effectively on a negative gradient, we know we want to make the weight more positive so that we move towards the minimum, and here where we've got a positive gradient we want to make the weight more negative so that we again head down towards the minimum. This is the same thing but for weight 5. Again, I've fixed the value of weight 1 and then varied weight 5 from -2 to 8 or 10 or so. And here it's a different shaped graph, but the same thing applies. We need to work out whether we're on an uphill gradient or a downhill gradient. If we're on a downhill gradient, we want to make the value bigger. If we're on an uphill gradient, we need to make the value smaller. Here I've combined the two, and effectively I've created a matrix of -2 to +4 and a -2 to +4 for weight 1 and weight 5, and then I've fed both values into the neural network to work out the overall error. So you can see if they're both -2, I get a fairly large error, and if they're both +4, I get a pretty large error as well. Naturally, somewhere in between is there a sweet spot. You can see I've used a conditional formatting rule here to colour these in, so anything below 0.25 I've coloured white, anything up to 5 I've coloured grey, and anything above 5 I've coloured kind of dark grey, so you can kind of see the valley of this 3-dimensional space. And clearly what we are aiming to do is get down to these lower values. I've created a little macro as well that if I press S, it will try and find the smaller values and find its way down into the valley. It's not quite perfect because it doesn't necessarily always pick the lower value, but you can see that whenever I head off down the valley, I end up in one of the lower values. Now you can see the lowest values are somewhere around here. I think the valley is level, it's just that because there's a gap between there and there probably is a 0 value that's somewhere between those two and somewhere between those two and somewhere between those two, which means that zeros do live all the way down there. And the lowest value I think is somewhere around here. There, 0.5 noughts and a 2. I've multiplied the values by 1,000 because then you can see them a little bit better. There's 4 zeros and a 8, so that looks a bit lower still. So I suspect that's probably around our minimum. 3 zeros 1, 4 zeros 2. Yes, that looks like our minimum over here. So clearly what we're going to need to do is to work out how to find our way down this valley. So that's what we're going to do next. We're going to look at some examples of how we can calculate the gradient, work out the gradient of where we are in the particular in the error function, work out whether we need to go left or right.